Hello everyone, my name is Matullah Shah and this is the lab part of Engineering Mechanics for undergrad batch 2019 section A, B and C. In today's lab video, I will demonstrate experiment number 5, which is the verification of law of friction. So this is sequence of my today video presentation. First, I will give you the introduction of experiment. Then I will briefly discuss the objective of experiment, followed by the procedure. Then I will tell you guys how to calculate the friction forces, and at the end part, which is related to you guys, where I will tell you what you guys have to do after watching this video presentation. So coming toward the introduction part. So first we have what is friction. So friction is a resisting or retarding force that always act opposite in the direction of motion. And we have different type of friction. The one which we are going to discuss in today's lab is a dry friction, also known as Coulomb friction, which occurs when unlubricated surfaces of two solids are in contact and slide or tend to slide from each other. The other type of frictions include fluid friction, which occur between the particle of fluids, which you guys will study in fluid mechanics course. The other one is the skin friction, also known as drag friction. This is the resisting force between fluid and solid. And the other one is the internal friction, which occur the same body as a result of shear deformation. So the friction which we are going to discuss today is a dry friction or Coulomb friction. So dry or a Coulomb friction. So in 1781, a French physicist known as Charles de Coulomb found that if friction is independent of area of contact, friction depends upon the nature of the surface in contact, and when an object is moving, friction is proportional and perpendicular to the normal force. So this is the law of friction. Friction is independent of area of contact. Friction depend upon the nature of surface in contact, and it is directly proportional to the normal force. So let's consider this figure. So here we can see that this is a body of mass m, and if I want to tend to move it in direction of p, so I will apply a load here p. So as it start moving, an opposite force F will be act in this direction. So if I draw the free body diagram of this body, so here we can see that the mass of this body is acting in downward direction. As a result, a reaction N will act on it. So this F is directly proportional to N. So in other words, if the weight of the body is high, the friction force will be high. Um, the friction force will be high. So here we can see in mathematical form, okay, friction is directly proportional to normal force. And if we remove this sign of proportionality, we replace it with a constant known as coefficient of static dry friction, and its value lies between 0 to 1, and it's depend on both the surface of contact. So it's vary from surface to surface. Like if two surfaces like wood and wood are in contact, its value will be different. Its value will be different for steel and wood contact. So which we will see in the further part of today lab. So coming toward the objective part, so our objective of this experiment is to verify the law of friction and to find the coefficient of friction between two surfaces. And this is the apparatus, adjustable wooden slide board with a slide pulley. Here we can see that this is adjustable wooden plate and this is the pulley. And with the help of this D we can change the angle of this apparatus as well. And weight hanger, this is the weight hanger with the help of which we will apply the weight, and wooden, copper and iron slider box. So here we can see there we will place a slider box on this wooden place. So we have different sliding box such as wooden box, copper box and iron box. And with the help of thread or rope we will connect this box with this hanger. So now coming toward the procedure part, what I have to do? First, I have to set the angle of this wooden plane. Let's suppose I set it 15 degree. It means I am interested to find the coefficient of friction, or I want to verify the lie of friction at 15 degree. Then what I have to do? I will weight the wooden box and place it on the wooden plate. So I will then weight this wooden box and then place it on the wooden plane. Then I will connect the wooden box with this hanger with the help of a wire. Then I will place the weight on the hanger until the box start moving. I will place the weight in this hanger until this box start moving on this plane. As the box start moving in this plane, I will stop adding weight on this hanger. Then I will further increase the weight of this box and again starting putting weight in this hanger. And as this box start moving, I will stop adding weight on this hanger. And I will note down the weight of hanger each time before increasing the weight of the wooden box placed here. So at the end, I will plot a graph between P, which is the weight which I am placing in hanger, and the normal force, and will find coefficient of friction graphically, which we will discuss in calculation part. And the same procedure I will be repeat for the other boxes such as iron and brass boxes. So this is the procedure in a video part, which is a lab demonstration lab demonstration which is coming in part 2. You will see this whole procedure and you will better understand there. Coming toward the calculation part, so you have to tabulate the data in this table. So coming towards this figure, here you can see that this is the weight of the wooden box which is acting downward. This is the weight of the hanger with the help of which you try to move this wooden box, and as a result a friction force is acting in opposite direction, and this is the normal force, and this is the theta of that wooden this is the angle of the wooden uh, inclined plane, and you are considering this coordinate axis. So what you have to do, you have to apply the equilibrium condition. First of all is the summation of horizontal forces is 0. So in horizontal forces you can see here, okay, you have the weight of the hanger is acting as horizontal force, so P. Then you have to divide the weight in its two rectangular components. So this is one component and this is the other component of the weight, and this is the theta. So the sine component of the weight is acting in horizontal direction, and then you have a mu s into n, which is a friction force. So you get first equation. Then you have to apply summation of vertical forces is equal to 0. In vertical forces you have normal force minus cos component of the weight which is acting downward is equal to 0. Now you have two unknown. One is the normal force and other is the mu s. So by solving simultaneously these two equations, you can easily find the normal force and the coefficient of friction if you know the value of the T, which is the weight of hanger, and W, which is the weight of this box. So this is how you will calculate the coefficient of friction from experimental data. Now what you guys have to do next, you have to watch the second part of this video, which is the lab demonstration, and then you have to analyze the data which is provided to you guys in Excel sheet. And on the basis of that data, you have to prepare a report. And that's all from my side. Thank you so much. Allah Hafiz.